Good morning students. Today we are again in front of you with the chapter of class 10 that is known as magnetic effect of electric current. In the last video we have learned about the magnetic field lines and the discovery of magnet. Today we will learn about Oersted experiment, Ampere swimming rule and the screw rule. First of all thing we have to do about Oersted experiment. First thing that we have to do about that is Oersted experiment. There was a scientist known as Hans Christian Oersted. There was a scientist known as, full name of Oersted was Hans Christian Oersted, done an experiment in the year 1820. What was the experiment? Oersted used to discover new things about the electricity. One day by mistake, this experiment was by mistake. One day by mistake Oersted left a magnetic needle near the current carrying wire. What he saw? He saw that there is a small deflection in the current carrying wire produces on magnetic needle. Let's see. Suppose that a current is there and current is passing from positive to negative terminal, positive to negative terminal, and if you will put a magnetic needle, it is magnetic needle near a current coil, magnetic needle near a current carrying wire, then it will get the deflection. This was the Oersted experiment. How this deflection is possible? Now question arises, how this deflection is possible? So this deflection is possible only because we know that magnet plus any other object, magnetic material, that is attract. If it is a magnetic material, then it will attract. But only we know that magnet used to repel. Magnet and magnet used to repel. Since there is a repulsion in the magnetic needle, that means Oersted concluded that current carrying wire behaves like a magnet. That means if in a wire we will allow the current to pass, then it will give us the magnetic field lines. And about the magnetic field lines already you have learned. But in which direction deflection will be there, Oersted can't able to explain. Then a scientist known as Ampere have given a rule that is known as Ampere swimming rule. With the help of Ampere swimming rule, full name of Ampere was Andrew Marie Ampere. So Ampere done an experiment and told that given a theory, or you can say a rule that is known as Ampere swimming rule, which will give you the direction of deflection. Let's see how. Suppose that same condition we are taking, current is passing from positive terminal to negative terminal. First case, current is passing in this direction. This is the direction of current. when current is passing in this direction, and suppose that how Ampere swimming rule. According to the Ampere swimming rule, imagine that according to the Ampere swimming rule, imagine that you are swimming in the direction of current. According to Ampere swimming rule, imagine that you are swimming in the direction of current such that current enters from your leg part and emerges out from your head part. Current enters from your leg part and emerges from your head part. Then the deflection is toward the left hand. Deflection is toward the left hand. How to write Ampere swimming rule? Write it. Imagine that you are swimming. Since it is a swimming rule, that means you have to swim. Imagine that you are swimming in the direction of current, such that current enters from your legs, and emerges, that means come out. Emerges means came out. Emerges from your head, then deflection is towards your left hand. Now, first case we have taken current is going from left to right, then deflection toward the left hand. That means if you are putting a magnetic needle like this, then deflection is toward the left hand. That means you can say this is the deflection toward the left. If you are swimming in the direction of current, the deflection is toward the left hand. Toward the left hand, deflection will be there. Now, one more case we can take. Suppose that current is flowing. Now, current is flowing in opposite direction. In first case, we have seen that current is going from left to right. In second case, we can take current is flowing from right to left. Then what will happen if current is going from right to left? Then we have to swim in the direction of current. Then deflection is toward left hand. Deflection is always toward left hand. Never that. Don't think that if you are swimming in this direction left to right, then deflection is toward the left hand, is toward the board. If the current is passing from right to left, then deflection is toward you, left hand only. Deflection will be always toward left hand. This is known as Ampere swimming rule because the scientist Andrew Mary Ampere have given this rule. Now, how to memorize this rule of technique you can say, rule you cannot say, snow rule. What snow rule tell us? Snow rule tell us that if we are moving from south to north, suppose that this is south and this is north, we can take current is passing from, suppose that we have got like this, plus minus. Suppose that it is south, it is north. If current is passing from south to north, if current is passing from south to, if current is passing from south to north direction, then deflection, then deflection towards. In which direction deflection will be there? If a current is passing from south to north, then the deflection of the magnetic needle is toward west. Deflection towards west. Which deflection? Deflection of magnetic needle. This is known as snow rule. This is known as snow rule. So today we have learned three things. First thing we have learned about Oersted experiment. Hans Christian Oersted in the year 1820 given us the experiment and proves that a current carrying wire behaves like a magnet. It used to produce magnetic field. It behaves like a magnet. Okay. Second thing we have learned about the Ampere swimming rule. According to Ampere swimming rule, imagine that a person is swimming in the direction of current. A person is swimming in the direction of current such that current enters. Imagine that. Only you have to imagine such that current enters from the leg part and emerges out from the head part. Current enters from the leg part and emerges out from the head part. Then the deflection of the magnetic needle is toward left hand. In both the cases, if current is going from left to right, then the deflection is toward the left hand. But if the current is going from right to left, again deflection is toward always left hand. Whether the current is going from left to right or right to left, deflection is always toward left hand. How to memorize this rule? We have developed a new thing that is known as snow rule. What is snow rule? Snow, S-N-O-W. If a current is passing from S to N, means south to north, then the deflection of the magnetic needle is toward west. This is known as snow rule, and by this technique we can remember the direction and deflection of the magnetic needle. In our next video, I will provide you the basic concept of three topics. First topic will be about current due to a straight wire carrying current. Magnetic field due to a straight wire. After that we will do magnetic field due to a circular loop of wire, and in the last part I will explain you the magnetic field due to a solenoid, in which you will know about what is the difference between electromagnet and solenoid. Both resembles, but there is a basic difference between solenoid and electromagnet. Now it's the time for assignment.